Alright, so this is going to be an example of a mixture problem. And generally, a mixture problem is you have two ideas that you're going to bring together and stir up in this big pot. So, my example is what I call the Nuts R Us example. So, Mary is the manager of Nuts R Us store. She has 65 pounds of cashews that seem to not be selling at $5.75 per pound. So Mary thinks that if she creates a mix of cashews and peanuts that'll sell for a little bit less at $4.79 per pound, she might be able to sell these cashews that are in stock. How many pounds of peanuts that normally sell for $3 a pound must be added to create this mixture? Now, generally, I highly suggest creating a table setup for mixture problems and put in there what you know. So, what we know about this whole problem is that we're dealing with two concepts. One of them being pounds, and the other one being the cost in dollars. And part of the cost in dollars is that per pound, but we're more interested in the value of the peanuts and the value of the cashews. All right, so then we also have peanuts and we have cashews. And we're going to mix them together, so eventually we're going to have a total mixture, total that we'll put down there at the end. So then the question becomes, do you know how many pounds of peanuts we're putting in here? And the answer to that is, I have no clue. So let's skip that one for a second. Do we know how many pounds of cashews? Well, yeah, because she has 65 pounds of cashews that are not selling. So this becomes 65. So let's go back to the peanuts. If you don't know something and the whole problem does not talk about the pounds of peanuts that you have, we're going to call that X. Now this part is really important because that X does not necessarily always go in that position for these problems. So we have to be a little cautious that these two cells, these two ideas, when we talk about total, always have to add up to the total. So in this case, we're going to get X plus 25. Oops. So in this case, we're going to get X plus 65. Now be careful, if we know the total poundage is 65, then we need those two other numbers under the peanuts and the cashews to still add up to 65, with one of them being an unknown. So that creates a different type of problem. All right, so let's talk about the cost. Well, I know the cost per pound for peanuts is $3 per pound, and I know I'm using X pounds of peanuts. So to find the value of it, the cost of it, it's going to be $3 times X. Because if you have a price per pound and you multiply by pounds, then the pounds are going to cancel and all you're left with is money. So that's kind of important to understand that we're not just multiplying these for the fun of it, we're multiplying because we're trying to find out how much it costs. So the same thing for the cashews, it's going to be 575, 575 times 65. And then the total cost, the mixture is going at $4.79 a pound, so this would be 4.79 times X plus 65. So the X pounds of peanuts plus the 65 pounds of cashews is going to equal our total poundage, which is interesting, but not that important. But this next line is really important. The amount of money that we're putting into peanuts, the amount of money we're putting into cashews has to equal the total amount of money. And that becomes our main equation. All right, so we need to solve for X. So we have 3X, 575 times 6.5. Let's see here. 575 times 65 is $373.75 is equal to 4.79x, and then 4.79 times 65. 311.35. Okay. All right, so now we can start solving for x. So I'm going to subtract both sides by 3x, the smaller of the two. Be really careful with decimals. You might want to put in 0, 0 if you're not going to do this on a calculator, to remind yourself not to subtract from the 9. I've seen people do that. And then we'll get 373.75 is equal to 1.79x plus 311.35. And then, of course, subtract that across. So 311.35, 311.35. I don't think I need a calculator for that. That looks easy. So this is, let's see, 0, 4, 2, 6. 6240 is equal to 1.79x. 3486. Now usually my directions for this would be round to the nearest whole number. So this would be 35 pounds. So it would be 35 pounds of x. Then you have to kind of remember where x came from. X was related to peanuts. So it would be 35 pounds of peanuts. And then your 65 pounds of cashews for a grand total of 100 pounds of nuts mixture that sells for $4.79 a pound. So that's a mixture problem. All right, so here's another mixture problem. The other setup I was kind of alluding to in the last example. I'm just going to set it up. I figure you could do the algebra part of it and see if you can come up with the right answers on your own. All right, so EON inherited $7,500, and she's going to invest this into two separate accounts. One of the investments earned her 7% simple interest in 1 year, and the other one earned her 9.5%. The total interest earned from both investments is $650. How much was invested into both accounts? Now, the formula that is being used here is I equals PRT. Interest equals principal times rate times time. But because the time is 1 year, then what happens is we're just dealing with interest equals principal times rate. So we're just looking for the interest by multiplying the principal times the rate. All right, so kind of like the cashews and peanuts mixture problem, this one is very similar. You're going to have, instead of the pounds, we're going to have the amount of money that we're putting in to both accounts. So I'm going to call those the P, the principals. And then down below, we're going to have the interest. Now that's also going to be money, and that might get a little confusing because there's two things going on here. We have interest rate, 9.5 and 7 are usually considered APR, which is annual percentage rate. So that can be read as 7% per year. So that's not interest the money, it's interest the rate. This I down here is interest the money. So we have two accounts. One of them is earning 7%, and the other one is earning 9.5%. So I'm going to write that as their titles. Kind of like peanuts and cashews. So my table is going to start off looking like this. And then again, we're going to have a column down here for total, because we're going to mix them together. All right, so how much principal do I have in total is what I know. So I'm going to go down to the end and enter that. Ewan has $7,500, so that's going to go down here in the total. A lot of people make the mistake of two things: putting 7,500 into 7% and 9%, or cutting $7,500 in half and putting half of it at 7% and half of it at 9.5. And nothing like that is said in this problem. So the only thing you can do is put $7,500 there. Now, how does the money split over the 7% and the 9%? Well, we don't know either of them, so I'm going to call the first one X. Now, remember what I was saying earlier, that when we talk about these two cells, they have to add up to the total. Now, the number I have to put into 9.5, when I add it to X, has to come to 7,500. So the X is going away. So one thing I know for sure is this is going to have a negative X in it. Because when I add those two together, there is no X in 7,500. The other thing that has to happen is it has to equal 7,500. So now I have it so that if I add X plus 7,500 minus X, the X's are going to cancel, and I'm back to 7,500. The other way to think about it is I'm using up X as my dollars, and this is what is left over. But for some reason, people don't like that thinking. All right, so now that I have X dollars as my principal of the 7% account, to find out how much interest there is, I'm going to use this formula. So it's going to be principal times rate. So my rate is 7%, but you have to change the 7% into its decimal format. So my suggestion, divide by 100. Don't be moving decimals, you might make a mistake. So it's 0.07 times X. Draw a line here and here. This one is going to be 0.095 times its principal. Make sure you put it in parentheses, minus X. And then the 7,500, it tells us how much interest is being earned on the total account. So down here, I'm just going to write 650. Okay. So the equation part of it is going to come from these boxes, and this is going to be the interest plus the interest. Let me change colors here. So this is going to be plus, and this will be equals 650. So it's the interest of the first account plus the interest of the second account is equal to the total amount of interest. And now you can go through and solve for X. So when you go through and solve for X, you're going to get X is equal to 2,500. And therefore, the other account, 7,500 minus X, is going to give you 5,000. So this is how much money was invested at 7%. This was how much money was invested and earned 9.5%. So make sure you can go through the algebra and get these answers. And this is generally how you set up mixture problems. Another type of linear equation application leans towards the geometric problem. Now, geometric problems, generally when you see that the problem is dealing with a rectangle, a triangle, a circle, the best thing that you can do is draw the picture. So here I have the perimeter of a fence surrounding a rectangular wrap around a pool and a patio is 196 feet, and we're going to try to find the uniform width of the patio, given that the pool is a 34 by 46 foot pool. All right, so we're going to start with a picture of what's going on. So I'm going to start with the fence. So the fence is a rectangle that is going around a patio and a pool. And then, therefore, I really just need one more rectangle, which is the pool itself. So between the pool and the fence is going to be the patio. Okay. The other thing I know is the pool is a 34 by 46. So the longer side is 46 feet, the shorter side is 34 feet. Okay. And then that idea of a uniform width of the patio, basically all that means is the distance between the pool and the fence is going to be the same whichever side of the pool we're talking about. So these distances all have to be exactly the same, And since I don't know them, I'm calling them x. Okay, so if I'm given this idea that the fencing is 196 feet all the way around, I'm going to need to know the dimensions of the larger rectangle. So when I start going for the dimensions of the larger rectangle, we need to know its length from side to side, and we need to know its width from up to down. Okay. So part of the lengths of these things are based on the pool. So the pool from here to here, this distance we know is 46. And the pool from here to here, we know this distance is 34. So it has these tails going off to the left and the right of 46 and 34, and those distances happen to be x. So this x here is, this distance, and this x on the bottom is that distance. So when we talk about what is the length of this pool, this part here, it is x plus 46 plus x, better known as 2x plus 46, or 46 plus 2x, doesn't matter which way you write it, but I'm going to put it in parentheses because it represents the length. So this will be L. And then the other side, it's x plus 34 plus x, so we can write that as 2x plus 34. And I'm again going to put it in parentheses because that represents W. Now, the perimeter formula for a whole rectangle is written as 2 times length plus 2 times width, because there's a length on the bottom of this rectangle and the top. There's the width on the right and another one on the left. But I know what the perimeter is. The perimeter is 196 feet. So I'm going to replace the P with 196. I know what the length is, so when I do a substitution for a letter, and it's not just a single number, I'm always going to put empty set of parentheses first, and then go back through and plug in 2x plus 46. And the same thing for the width. I'm going to substitute something in for W, so I'm going to give it a little space, and that one is 2x plus 34. All right, so I'm going to let you do the algebra part of it. The answer is supposed to come out to be 4.5 feet. So the width of the patio is 4.5 feet. So go through the algebra and see if you can get to the answer. Good luck.